Alright, our objective today is that you are solving equations using inverse operations, and this time that's going to involve logarithms. Now, we've learned a lot about solving equations, so let's just recap really quickly. The way we're going to do this is that we need to get rid of everything that's outside of the log, and then the log, and then stuff inside. Now, in this case, there's nothing inside, but if you look at the next example, there will be. So again, that's everything outside the log, and then the log, and then stuff inside. So in this case, you probably know what to do to start, even if you're not quite sure what we're going to do eventually, and that's to add 5 on both sides. You don't need to write that if you don't want to, but you do need to write the next line. So that's 4 log base 6 of x is equal to 22. Now we're going to divide by 4 so that we have the log by itself, and we can deal with that. That's going to give me log base 6 of x is equal to 5.5. And now we need to get rid of this log. Now this is new. This is not divide, this is not multiply or exponent or anything like that. To get rid of a log with a base, you raise each side as an exponent to that base. So since this is base 6, I'm going to do 6 to this power is equal to 6 to that power. Now I'm going to kind of rewrite this over here just so you see. What I'm actually writing here is 6 to the log base 6 of x is equal to 6 to the 5.5. When I write these big 6's down here, this is what I'm writing. So, you know how these 5's cancel out and these 4's cancel out? Well, guess what? 6 to the power of and log base 6, they cancel out. And all we're left with is x. X equals 6 to the 5.5. When you type that into your calculator, you get 19,047.23 approximately. So that is it. To check your answer, you can plug it back into this equation, and it should come out to approximately 17 because I did round my answer a little bit. Let's take a look at the next one. Again, we need to get rid of everything outside the log, and then the log, and then the inside stuff. So our first step in this case will be to subtract 16 on both sides. That's going to give me negative 1.5 on the left is equal to negative log of 4x plus 7. Now, that negative also needs to be gotten rid of, and remember that negative is a coefficient of negative 1, so I'm going to divide both sides by negative 1. Again, you don't have to show these blue steps unless you choose to. This is going to give me 1.5 is equal to log of 4x plus 7. And now we can get rid of the log. Now the base of this log is 10. Remember, if it's not written and it says log, it's base 10. So we're going to do 10 to the 1.5 is equal to 10 to the log of 4x plus 7. And those cancel out. That's the point of doing this. So on one side, we have 4x plus 7. And on the other side, we have 10 to the 1.5, which I'm typing in my calculator. And this comes out to be 31.62. Sorry, it's a little tight. Now, from here on out, you should notice this is just an Algebra 1 problem. So we're going to subtract 7 on both sides, and I'll show work. But again, this easy stuff, you probably don't have to. So that gives us, I'm going to write it over here for space, 24.62 is equal to 4x. And so then our last step will be to divide by 4, of course. And that gives us 6.16. So my answer is x is equal to 6.16. Notice, nothing about this was new except for the log part, just how do you get rid of that log. And to recap, we got rid of the stuff outside the log first, and then the log itself, and then the stuff inside. That's the order you'll always follow. So our objective was solving equations using inverse operations, particularly we were getting rid of logarithms.